Hey everyone, Mr. Voikin here. This is Unit 7, Lesson 9. We're continuing on with function notation. And remember from the last video, basically we can write it in two different formats. So function notation looks like this: f of x, which is essentially the y equals 3x plus 1. And with the other one, which they're calling the xy notation, they're starting off with y, which can essentially be substituted with the f of x equals 3x plus 1. So just two different ways to represent the same thing. So let's take a look at the class example number 1. It says use a graphing calculator to calculate or to sketch the graph of the function f of x equals 3x plus 1. Okay, so in this case, we're going to go to this button on our calculator that says y equals. And you can see that it's saying y0x, which is basically like f of x. So all I have to do right here is just go 3, click on this button to get the x, and then plus 1. And then what you want to do is go to your window. And usually we're going to start off with an x min. So that's to the left 10, negative 10. To the x max is usually defaulted again to the right, positive 10. And the y min is going down from the origin, so negative 10. And y max is going up from the origin, which would be positive 10. And now if I graph it, you can see that is our graph right there. Now, in order for us to graph this on the paper right here, we essentially need a couple points. And the 2 points that we're usually trying to go for are the y-intercept and the x-intercept. So to calculate the y-intercept, you're just going to type in the calc button. So press the calc button, then press 0, and then press enter. Okay, now that's on the TI-84. See what happens here. So if I press calc right here in this box, I'm going to say 0. So it's basically saying x equals 0. When I press on calculate, what is y? And it says right here that y is 1. So when x is 0, y is 1. So on my graph right here, we're basically going to have like 1, 2, 3, 4. And I want to equally space these. So I'm going down 4. And at 1, that is going to be my y-intercept. Now, what is the x-intercept? So on our TI-84 calculator, to calculate the x-intercept, you're going to press the second button, and then let's go back to the calculator here and see if we have that. It's a little bit different here on the graph. Yeah, so anyways, on the calculator, you're going to press second, calc, and then you're going to choose the 0 function. And then what you're going to have to do is draw a line that's left of the intersection, then draw a line that's right of the intersection. It's going to give you sort of 2 little arrows pointing in. And then when you press enter again, it's going to find the x-intercept that is between these 2 lines. But on this Calc 84 app, let's see if I press trace. No, so calc. And here's the 0 right here, 0, and it says go to the left. So I'm not actually sure what to type in here, so I'm going to choose sort of -5. So I went quite to the left of where the x-intercept is, and to the right I'll just go with 5 and hit calculate. And it says when y equals 0, x equals 0.3333. And that looks about right. So again, moving over 1, 2, 3, 4, 1, 2, 3, 4 even spaces. 0.3333 would sort of be less than the halfway point right there. And I would have a line that goes through those 2 points, forever down and forever up. So forever down to the left and forever up to the right. Okay. The other thing we can do is look at a table. So you can see here that I've got 2 points that don't have any decimals. So -10 and 29. When I go to the value 9, I've got -9 and 26. And so you can go find these other points that are on there. Like, so for example, if I go to 2, well, let's not use that one. Let's use 1 in the X. It's going to be 4 in the Y. So that's basically telling me to go over to the 1, which is right up here. And then that should line up with that point. And I have another point that is 1 in the X and 4 in the Y. Okay, class example number 2. It says, in each case, express the relation in function notation that is given in function notation as an equation in 2 variables. Well, this is actually just ridiculously easy. Just replace the f of x with a y. That's it. And the g of x just replace with a y. It's that easy. The second one, express the relation that has 2 variables in function notation. So just replace the y with an f of x. Okay, and it says the graph of the function defined by y equals f of x has the equation y equals 4 minus 3x. Express the equation in function notation. Again, just replace the y with f of x. So simple. Okay, class example number 3. It says we've got a graph right here. And part A says f of 5. What is f of 5? So basically when x is 5, what is f of 5? So what I want to do is find the x equals 5. So 1, 2, 3, 4, 5. And then I want to go down till I hit the graph and then back over. And that's at -2. So the answer here, f of 5 equals -2. What about f of -2? So what is the value of y when x is -2? So I go 1, 2, and I can go up to hit the graph, then over to the y, and that's going to be up 3. So the answer here is 3. And f of 4, I just want to again go 1, 2, 3, 4, go down, then back over to the y-axis, and it is -1. Okay, write the ordered pairs associated with the last part A. And that's, again, quite simple. Remember that the x is first and the y is second. So when x is 5, y is -2. When x is -2, y is 3. And when x is 4, y is -1. Okay, now we're saying we know the f of x. In this case, it equals -1. So what is the value of y, or of x? Now remember, this is just basically y. So we're saying y equals -1. So what is the value of x? So y is -1. That's going from the origin down 1. Then I go find the graph. It's over here. And I go back up. That's 4. So if f of x equals -1, then x equals 4. If f of x is 3, so again, that's basically y is 3. So go from the origin up 3, 1, 2, 3, go over to the, hit the graph and go down, and we are at an x value of 2. Okay, and f of x equals 4. So again, go from the origin 1, 2, 3, 4. Now, I guess I got to go back. This f of 3 really had 2 values, so I just want to do that again. Wasn't looking close enough, so going from the origin, I'm going up 3. 1, 2, 3. Notice that I can go to the right and to the left. So we hit 2 and we also hit the negative 2. So x in this case is 2 and negative 2. Okay, and so we'll do the same thing for when f of x equals 4. So go from the origin 1, 2, 3, 4. And I can go to the right and I can go to the left. And when I go down, back down to the x, you can see I'm at positive and negative 1. So x equals positive negative 1. Okay, part D. Use the notation in A to make a statement about points A and B on the graph. Equals 1. And point B right here, that's going to be f of 6 equals down 1, 2, 3, negative 3. Okay, and write the x and y intercepts. So here's the y-intercept, there's 1, and the x-intercept, there's actually 2 of them, 1, 2. Okay, so for the y-intercept, we know that x is equal to 0. So for the y-intercept, it's going to be f of 0 equals 5. Does the y value equal 0? And the other one, f of 3 equals 0. The range is the values of y, the possible values of y. Now they're using f of x here, but remember we know that f of x is the same thing as y. So we look at, the way we read this is we say x is such that the x right here, now if we look at that symbol to the left of it, it's saying x is greater than or equal to, and it's this point right here, which is negative 6. So it's equal to negative 6, and values going to the right, which would be greater than. And where does it go to on the other end? It goes right to this point right here. So that's 5, 6, 7. So it's from there going backwards. So to the left, which is less than. So that's what this reads right here, is x is less than or equal to a positive 7. And this right here states that it can be every value in between those that are real numbers. Okay, what about the y values? Well, where's the top? Right there. And where's the bottom? Right there. So it's basically everything that's in between the top and bottom points. So the way this reads is the f of x, or in this case y, is greater than, so that would be the lower number. So greater than looks like a negative 4. And it is less than, at the top there, 5, and it is a subset of all real numbers. And there we go. That was a short one, and now you're moving on to the assignment, page 472. And as usual, the answers are at the end on page 476. See you in class.